So, fooling the HCH2 inverter. This is the circuit board from an inverter module. I took it off the IGBT because I was interested in looking at how it all went together. So this is one I've had for quite a long time. So basically I've wired it up to my power supply so you can power the board with 12 volts. And I just wanted to basically examine these phase sensors to see what they were doing. There's 3 phase sensors. There's also a battery current sensor, which we'll look at later. But the first thing to try and defeat was the phase sensors. They obviously sense the current in the phase motor wires. And in the Insight, what has been possible to do is to fool them in such a way as to increase the current considerably by making the sensor input into the board here a percentage lower than it would otherwise be, and you do that on all of the sensors. So I took one off to have a look at it, and on one of the other ones on the board I passed a wire through the sensor in the same way as the motor phase wires go through, and then we have a supply here to give us a 30 or 40 amp supply, and then I have my adjustable load, which is very accurate, so I can set that to like 10 amps, 20 amps, 30 amps up in steps, and then I can measure the voltage. It's a simple 3-terminal sensor, so we've got plus 5 volts and ground, and then we've got the signal output, and you can measure the voltage that the sensor outputs for a known current flowing through it in either direction. They normally rest at 2.5 volts, and that means that 0 amps is flowing. So basically I've passed current through this, various levels of current, 10, 20, 30 amps, etc. Noted down the voltage that's developed between ground and the signal pin here. And after looking at that, I could see how much the increments were, etc., for the changes in current. So what I then did was you trace the circuit for the phase sensor, and in the Insight one there was a resistor. It was sort of an output resistor in the output side before it went into the MCM, but in this there isn't. So what I did was I snipped the input connector. I snipped the input wire here, and I put in series with the output from the sensor and the input into the board. So in between the two, basically I put a 220R resistor. So that's effectively a resistor in the output from the sensor. And then on the MCM board side of the input, I put a 1K resistor, 2 1K resistors, pulling it up and down to 5 volts and ground. So basically it tries harder to keep it at 2.5 volts, and it forms like a potential divider. These resistors form a potential divider with the 220R resistor. So as the current flows through and changes, the voltage changes, but now the voltage that this sees, the motor control module sees, is a percentage lower than it would be. It's actually about 30% lower, so the motor controller now only sees about 70% of the current that is passing through, or the voltage proportional to the current that is passing through. So in order for it to command the level of current that it wants, it has to open the gates wider on the big transistors which can control the actual motor to increase the power to match what it thinks is 100 amps. So if we imagine there's 100 amps passing through these, this is only going to actually see 70 amps. So what it then has to do is it has to crank up the current until it sees the 100 amps that it wants to see, and actually at that point there will be about 140 amps actually flowing. So that's a way to do it. Now obviously the modification, a bit of a fiddle. I have to cut one wire here, insert a 220R resistor, and then solder on a couple of resistors here. Now obviously I've just hacked this onto this just for some very rough testing. And there's also a 10K pull-up resistor on the board here, or pull down resistor, and that's probably just for fault detection. So I'm actually going to unsolder that on all of the phase sensors here, just to try and see what that does. That pulls down to ground, but because the output from the op-amp phase sensor is quite strong, it obviously would normally override this, but if the signal failed, then this would pull down to ground, and that would then develop a DTC and a fault code. So I think if we can probably remove this, and then it will stop it influencing our potential divider, which we've set up with the 220R and the 1K resistor. So I don't see any major problem with removing that. But on this test board, which is no use apart from this testing, I'll take the 10K resistor off and redo my measurements and see if it affects it negatively in any way. So that'll be defeating the phase sensors on the HCH2 motor control module, and looking at the wires, etc., I think it will, and the rotor position sensor, etc., I think it probably will actually connect straight into the CRZ. So we shall see if it does, if an HCH2 battery IMA assembly will work in a CRZ, then potentially we've got quite a high voltage potential here, because the HCH2 operates at a higher voltage than the CRZ as standard. And as I've already tested, the DC to DC converter can stand at least 220 volts. So potentially this MCM inverter here might stand 200 or so, and that gets us into the pretty high teens kilowatt power outputs. Certainly I'm hoping to get at least 30, and if I could get 30 with the HCH2, that would be great. That would be 200 volts at 140 amps, but hopefully we can get a few more amps out of this, and we may be able to squeeze up to 220, and then we're well into 30 kilowatt territory. So that's where we are at the moment, still just doing research and development.